So today we're going to be talking about horizontal gaze palsy and how we can differentiate supranuclear, which is above supra, from nuclear, which is the starting point of the nuclear and infranuclear pathway, and the infranuclear pathway, which includes the nerve, the muscle, and the neuromuscular junction. So it could be the nerve, the muscle, and neuromuscular junction. So when you can't look horizontally, let's say you can't look to the left, the supranuclear pathway control for looking to the left is mediated by cortex, frontal eye field, and parieto-occipital temporal region, ipsilateral for pursuit and contralateral for saccade. That meets in the final common pathway in the pons, which is the parapontine reticular formation and the cranial nerve 6 nuclei. The cranial nerve 6 nucleus is the final common pathway for horizontal gaze because it supplies both the ipsilateral lateral rectus muscle, but also the contralateral medial rectus muscle, and that's the cranial nerve 3 in the midbrain. And so that thing is called the medial longitudinal fasciculus. The medial longitudinal fasciculus coordinates and yokes together the medial rectus of one eye to the lateral rectus of the other eye. And so when you have supranuclear input to the horizontal gaze center in the pons, it makes your eyes look to the left or to the right. And so one of the ways we can tell it's supranuclear, which means it's above this nucleus, is we can stimulate the pons and stimulate the cranial nerve 6 with the cranial nerve 8, which is the vestibular ocular reflex. So a doll's head maneuver basically stimulates your ear, and that tells your eyes to have counter rolling. And so if we can make the eyes move in a horizontal gaze palsy with the doll's head maneuver, that proves that everything from the nucleus down is intact. The nuclear pathway, the infranuclear pathway, the nerve, the muscle, and junction are fine because the eye can move, and that is how we determine if it's supranuclear. If it's a infranuclear problem, that could be the nerve, 6th nerve on one side and 3rd nerve on the other side. That would be a very strange combination to have nerve involvement for. So if it's nerve, it usually involves other eye movements. So it'd be very unlikely to be a combined partial 3rd and partial 6th to cause a horizontal gaze palsy in isolation. Normally there'd be ptosis or ophthalmoplegia or pupil involvement or something else. The muscle, the most common muscle disease causing this is thyroid eye disease, but anything that damages the muscle, but it has to be bilateral, could produce the horizontal gaze palsy on an infranuclear basis. And of course, myasthenia gravis, the neuromuscular junction, can mimic any pattern of painless, pupil-spared, non-proptotic ophthalmoplegia, including the horizontal gaze palsy. So it can always be myasthenia gravis. The nuclear one is actually the most common cause of the horizontal gaze palsy if you have a doll's head maneuver that doesn't make the eyes move. The nuclear lesion is in the pons, and that just tells you where it is. It doesn't tell you what it is. Demyelination, trauma, tumor, infection, stroke, all could affect the cranial nerve nucleus 6. And because the PPRF lives right next to the 6th nerve nucleus, it's very hard to differentiate these. However, if there's a difference between the saccade and the pursuit, saccade deficit but normal pursuit, then that's going to be more PPRF because the 6th nerve nucleus is the final common pathway for both saccade and pursuit. And so when you're dealing with a horizontal gaze palsy, you can't look to the left. The first thing you're going to do is the doll's head maneuver. If it moves, it's supranuclear. If it doesn't move, nuclear versus infranuclear. It could always be myasthenia. You got to image this person to look at the nucleus. You're going to be thinking about the muscle. That means you have to order the orbit, head and orbit, usually MRI. And it's unlikely to be the nerve, but it could be the nerve. And the way that it could be a nerve is if you have this fascicle of 6th plus an internuclear ophthalmoplegia on the other side. And so there are different combinations that you can get to the internuclear version of the horizontal gaze palsy, but really pons. And you have to image that because you can't tell what the cause is. You can only tell where the problem is, not what the problem is in a horizontal gaze palsy.